Tell me, why do we need time? So if you want to measure some time, right? I mean, for example, you have seen like washing machine, microwave oven. So these are all like basically microcontroller based device. So whenever you want to uh, measure some time, right? So in that scenarios, we use timers, okay? Timers or counters. So timers like in the 8051, we have 16-bit timers, 16-bit timers, and like 16-bit two timers, 16-bit two timers. When I say 16-bit, how many counts it can count? Totally, it can count 2 power 16 counts. 2 power
Yeah.
16 counts. So you know that like we have the clock connected to microcontroller. Clock connected to microcontroller. So how do we measure the time using this one? So for example, uh, this period of the clock, like if I say this is like 1 megahertz clock, 1 megahertz clock, then what is the period of this clock in terms of seconds? It is 1 by
So what?
frequency. That is, if I say the frequency of the clock is 1 megahertz, then in terms of time, period of clock will be 1 microsecond. Okay? 1 microsecond. So if I connect this 1 microsecond clock to the timer, every microsecond, every count, basically the duration of this count is 1 microsecond. So if someone asks you to create a delay of 1 millisecond, basically you have to multiply this by 1000, which will create the delay as 1 millisecond, right? So then what I have to do, I have to load this value to your timer, 16-bit timer, right? So can you tell me what is the maximum delay if this, like if your timer is connected with 1 megahertz, what is the maximum delay I can have in 16-bit timer? That is 1 micro into 2 power 16. This is the maximum delay I can have using timer. Okay. So timer also it can be used as counters. Whether my screen is visible to you?
Yes, sir. Yeah.
Okay. So this timer, it can also use it as counter. For example, you have you have a sensor at your door, for example, in your college entrance. So you can have a design like every person in each door, so you can count. So every usually this counter function will be working on interrupt. So whenever we get the pulses, we're going to count how many. That is the functionality of count. So 8051 is how many bit microcontroller basically? It's a 8-bit microcontroller, right? So basically
Yes,
it's a
sir.
8-bit microcontroller, so you can process only 8-bit data. But this timer is a 16-bit, right? That's why, like for example, if you want to load a data, all the registers, you know, the 8051.
So your voice is kind of breaking.
Is it?
Yeah. It's
Is
a
it clear now?
dash, some
Pardon?
echo, echo.
Okay. Is it clear now?
So there's an echo.
Okay. What about now?
Yes, sir. Now it's clear.
Okay. So, like our 8051 is basically a 8-bit processor, right? 8-bit controller. So now our timers are like 16-bit. So how do we deal with this mismatch? Like basically, for dealing with this, like 8-bit to 16-bit data movement, right? Or I mean, can you name some registers which are present in 8051? We have like R0, R1, accumulator. All these registers are of 8-bit, right? 8-bit. So for that reason, for example, if you want to move some data that is like 8-bit data from some register like R1, R2, R3 to a timer, okay, then the best way is like they have divided this timer into two subparts. That is actually, I said like timer is 16-bit, right? So they have divided this timer into TH and TL. TH and TL. Each of 8-bit. Each of 8-bit. Okay. So the higher bit of the 16, higher byte of the 16-bit register, we call it as TH, and lower byte of this 16-bit register we call it as TL. Okay.
Yes, sir.
So I'll put the screenshot of those two registers. Yes. So here, if you see this particular register addressing, so if you want to access any data from this TL0, then like in generally, if you want to move any data from one register to another register, how do you do that? Like basically using move A comma R5. This is the way how you usually move the data, right? So the same way we can move the data to TL0 or TH0. Okay, so the base address of these two registers are 8AH and 8CH. So I mentioned you that like if I want to have a delay of 1000, that 1 millisecond with the connected clock of 1 microsecond, then I have to load 1000 items, right? So how do I do that? Actually, I have to move that value, like move TH0 with MSB of this 1000 and move TL0 with LSB of those values. Okay, so that is how I uh, move the values, and like I set the delay. Clear?
Yes, sir.
Same way, similar way, like how many timers are there in 8051? Initially I said there are two timers, right? Two timers. Two timers. So this TL0 and TH0 corresponds to timer 0. Timer 0. Same way we have TH1 and TL1 corresponds to timer 1. Timer 1. Okay. So how actually this timer works? So basically this timer, right, it's like a counter. it starts from 0. These values, right? TH0 and TL0. This value starts from 0 and it goes up to the maximum value, that is FF. So it is basically a 16 bit, right? So this is 8 bit, this is 8 bit. So how do I control delay using this timer? For example, every time it reaches FF, right, we are going to get one signal saying that it reached the maximum value. So if I want to have a delay of like some millisecond, 1 millisecond, right? So then I said like I want to load the value of 1000. So in that scenario, what I do, like I will load the counter, that TH0 or TL0, with FF minus this 1000, okay, FFF minus 1000 to this TH0 and TL0, such a way that every time it reaches to this FFFF, right, we are going to get one pulse. That we call it as rollover condition. Rollover condition. Are you getting like what I'm trying to say? If you want me to repeat, I
Yes, sir.
can repeat. Huh?
Okay, can you repeat it, sir?
Yes. So, did you get like the two registers, like 16 bit registers are that is basically to store the count, right?
Hmm. Yeah.
Yes. Now, I said like that was an example. So every clock cycle, what is the delay? 1 microsecond. 1 microsecond, right?
Yes, sir.
Every clock cycle, it is 1 microsecond. So actually, when I say every clock cycle, it is corresponds to every count. Every count. Okay, every count, that count is actually these values. Every clock cycle, one count will be incremented. So if I like at this rising edge, one count will be incremented. At this rising edge, another count will be incremented. So one count equals to 1 microsecond. When I say it is like counter reached 2, then it is corresponds to 2 microseconds, right? 2 microseconds. Same way, if I want to have 10 microsecond, what I do, I should have 10 counts, right? 10 counts. 10 counts. Correct?
Yes, sir.
Yes. The same way, like whenever this counter starts from 0, this TH0 or TL0, it starts from 0 and it reaches maximum, that is FFF. Because FFFF is like maximum you can have it in the 16 bits, right? 16 bits. So whenever it reaches FFFF, so we are going to get one pulse from timer. So if I just load FFFE, and how many counts I need to reach to FFFF? Initial value, you assume it is FFFE. Okay, initial value of the timer is FFFE. And how many counts it takes to reach to this FFFF?
So I didn't get.
How much?
So I didn't get it. I didn't get understand.
So, for example, 0x FFFE is a count, right? It's a count.
Okay.
So, how many count you have to add to this FFFE to make it FFFF?
Um.
One count, right? If I add 1 to FFFE,
One. Yes.
it's going to
Yeah.
FFFE,
Huh.
right?
Yeah.
So,
Huh.
you know that like every time it becomes this timer becomes FFF,
Hmm.
you are going to get one pulse. That you're clear, right?
Hmm. Now I got. Huh.
So now if I load this FFFE to this timer, what happens?
Hmm.
I mean, I said like every time it is going to increment, this counter is going to increment. So it takes one count
Hmm.
to increment, right? To reach from FFFE to FFFF. So
Yeah. Hmm.
basically in 1 microsecond, I will get one pulse. So every time if I keep loading this FFFE to this timer,
It increases.
1 microsecond,
Hmm.
I keep getting this pulse, correct?
Yes. Yes.
So now, if I want to get like every 10 microsecond one pulse, what I have to load? I have to load FFFF minus 10, correct?
Huh.
Because it takes 10 counts when I load FFF minus 10 to this timer, then it takes actually every 10 count I'll get one pulse. So every 10 microsecond I can generate one pulse, right?
Yes, sir.
Yes, that's where actually if you want to generate some delay based on the clock what you have to load maximum value FFFF minus how much delay count you want, that you have to load to these timers. Then you can generate those delays. Now you are clear?
Huh. Okay.
Got it, right?
Yeah.
Yes. So this is basically your timer registers. But there are various modes in which you can operate this time. So that mode of operation can be controlled using T-mod and T-con registers. T-mod and T-con registers. Okay.
Yes, sir.
So T-con register is actually 8-bit register. T-con is 8-bit register. The bits of these T-con registers are TF1, TR1, TF0, TR0, IE1, IT1, IE0, IT0. Okay. So here the upper 4 bits, wherever you see T, that are used for timers, and lower 4 bits are used for counters. I said this can be also used as a counter, right? These registers can be also used for counter, like I gave you an example, like counting how many people entered the room. So you can use also as a counter. So if you are using that timer as a counter, then these registers are used. If you are using for measuring the time, I shown you like how to measure the time, then these 4 bits are used. Okay.
Yes, sir.
So here the TF1 register, it is basically a overflow flag. Overflow. So I said whenever it reaches maximum, the timer reaches maximum, you are going to get one pulse. I said, right? So that pulse you can read through this TF1. So whenever it reaches maximum FF, so this bit is going to become high. So here you can say it reached the maximum, and you can measure the time. I mean, you have to keep monitoring this time. So whenever it reaches this maximum value, then you can say that it reached the maximum. Did you get that point?
Sir, can I
Hello?
repeat it? Can I repeat it, sir?
Yes. Whenever your timer reaches FFFF, I mentioned that you're going to get one pulse, right?
Yes. Huh.
That pulse you can read through this bit of this Tcon. So the Tcon registers MSB will have that bit. So if you read whenever it becomes TF1 becomes high, that means your timer reached FFF. Clear?
Yeah. Okay.
So when to start this? I said like you can start the timer from some value and it reaches the maximum. When to start that timer? So this TR1 act like a enabling of the timer. So this TR1 basically enables your timer. Whenever you set this TR1 to high, then your timer starts running. Whenever you make it 0, this timer stops counting. So for example, whenever you make this TR1 high, so if you load like FD, then as soon as you make this 1, then it starts counting FFFE and FFFF. Then again it loads to FFFD. And as soon as you make it 0, right, your counter value keeps stuck at that point. It will be like always FF50 at this point. So this is actually halt or enable. Clear?
Yes.
And this F1 and R1 is for timer 1, and same way it is for timer 0, because I said 8051 has how many timers? 2 timers. For that reason, we have 2 control bits. Whether you want to start a timer 1 or timer 0, this will basically using this we control. Clear? So
Yes.
coming to these parts, like the counter parts. So here this IE1, IE0 is used to enable your timers as counters. So it is actually enable bit. So as soon as you enable it, your counter starts counting. Okay. Every edge, like, so here in the timer, what happens? As soon as it reaches some point, it is going to generate pulse. But here, as soon as you get the pulse from somewhere, you are starting counting. I said, like, as soon as number of people enters to the room, so it is going to count the number of people, right? So you may have one sensor which counts, which detects people entering the room. As soon as people entering the room, it generates one pulse. So that this counter will be keep incrementing. In that way, you can use. Okay.
Yes.
So actually, this IE1, right, also controls your edge. So IE1 basically we call it as a timer edge. Okay. So it also says whether you want to count the positive edge or negative edge. So this edge control, edge control flag, edge flag is okay. IE. That's why interrupt edge flag. And IT1, it's like whether to enable the interrupt or disable the interrupt, like whether you want to count the interrupt or disable the counter. So whether you want to enable this counter every edge, whether you want to count it or disable it. Okay. So if this bit is set 1, if this bit is set to 1, then this interrupt, right, every falling edge, this interrupt will be enabled. Falling edge means like from high to low, any signal you receive high to low, then this interrupt will be enabled. So if it is set to 0, so this will be level triggered, not edge. Okay, level triggered. So level triggered in the sense, if it is low, then this interrupt will be triggered. So this basically IT1 decides whether your interrupt is edge triggered or level triggered. So interrupt basically used for your counter application. Okay. So that is about T-mod register. So we saw like the timer register, T-mod registers. Next, basically, T-con, yeah. So far we saw T-con register. Next is actually T-mod register. T-mod register. I mean, few of the things you may feel confused right now, but when we see the example program, right, you will get a clarity on this. I'll come back to this, whatever we discussed here, and we will see the program, so you'll get a clear idea. Okay. So T-mod is again, we have 8-bit. So in that, these 8 bits divided into 4 bits. The lower 4 bit is actually timer 1, higher 4 bit timer 1, lower 4 bit is assigned to timer 0. So the LSB bit is gate. Here also the fourth bit is gate. And here, whether you are operating as a counter or timer. So we said that like we can operate in the timer or counter, right? These registers. So you have to select using this counter or timer. And we have 2 bits, that is modes. Which mode of operation you are using? M1, M0, M1, M0. So mode, there are like various modes. How you have to operate, like from where to get the clock. I said one example, you can have a 1 microsecond clock. The same way, you can control this clock with a different frequencies. Okay, so that basically we control using various modes. Okay.
Yes.
So if you set this gate flag to 0, right? Gate flag to 0, then timer can be controlled using TR and TF bits. So using this TR and TF bit, right, you can control the clock. Okay, you can control the timer. If the gate is 1, if the gate is 1, then your timer will be purely controlled by external clock source. Okay, so this is clear, right? Timer or counter. Timer or counter. So whether you are operating your timer as a timer mode, that is like measuring the delay, or whether you are operating it as a counter mode, that is counting the counts. And mode bits are very important. We have 4 modes: M0, M1. If it is 00, that is mode 0, then we are operating at 13-bit timer mode. If it is 01, then 16-bit timer mode. If it is 10, then 8-bit with auto reload. And if it is 11, it means split timer. So here we have that 16 bits, right? The timer has 16-bit register. So if you choose it as a 00, then the timer will become just 13-bit. Okay, maximum count what you can have is 2 power 13. If it is 01, then full 16-bit mode you can operate. And if it is 10, only 8-bit you will be operating. And when I say auto reload, so if it is not auto reload, right, every time it reaches FFFF, you have to reset. I said like you have to reset to that FFF minus 10, that is like FFF A, maybe like FFF 0 you consider. Then every time you have to keep reloading. Whenever it reaches maximum, right, you have to reset the timer value to FFF. Okay, but when you set it as auto reload, so it will automatically reload this value. Okay, so as soon as it reaches FFF, so it will reset to FFF 0. That we call it as auto reload mode. And split timer, you can use it as like MSB 8-bit as one timer, LSB 8-bit as another timer. This we call it as split timer mode. 2 timers we can have, 8 bits. Clear?
Yes, sir.
Okay. So first we will see mode 1. That I said like mode 1 is how many bit mode actually? Mode 0, mode 0. A mode 1 we can take initially. It is most popular mode. Mode 1, how many bit timer mode actually? Mode 1? It's a 16-bit, right?
30.
16-bit timer.
Okay.
16-bit timer. So when I
Mode
say,
1 is 16 bit, sir.
huh?
Mode 1 is 16 bit.
Yes.
Okay.
So it starts from 00.
Okay.
Maximum value what it can have is FF,
1.
FF, the maximum.
Okay.
Correct? So in this
Yes, sir.
mode, TH and TL both will be used. Each are of 8 bit. So since like we will be using both the 16 bits, so we will be using both timers. So we have to use this TL and TH, both the registers. Okay. So what
Yes.
in this mode, right? How we use the timer is first stage of using this timer is we load TH and TL register, like what time we want to count, right? Based on that, we load TH and TL registers. So then we want to start the timer, right? How do you start the timer? Using TCON register. In that, I told you that like TR bit is basically starting the timer, correct? So that is where we have to set bit. If you remember, like in the first unit you might have studied, set bit sets the particular bit. I will set TR0. I will make TR0 is high. So as soon as I make TR0 high, your timer starts counting. So if it is timer 0, then TR0. If it is timer 1, TR1. Okay. So
Yes.
then whenever, as soon as you start this, whenever your TH and TL reaches maximum count, that is FF, then then you are going to generate one flag in TF. TF is going to generate a flag. It means it is going to generate a pulse. That delayed pulse it will generate. So then you can say that like, okay, my timer completed 1 microsecond. My timer completed 2 microseconds. That's how we measure. So step one is we load TH and TL. Step two, we start the timer with using TR0. As soon as we start the timer using TR0, we have to monitor this TF0, whether we reached, whether like that pulse is generated. That pulse you can read using this. Okay.
Yes, sir.
Steps, 3 steps you have to remember in mode 0, mode 1. Okay.
Yes.
Okay. So maybe today we will pause the session. We will continue tomorrow. Okay.
Okay, sir. Same
Okay.
time, right?
Same time.